The 2.3 lecture for Algebra 2 introduces histograms. And the difference with histograms and bar graphs would be, for example, histograms would be more of a continuous set of numbers. So if you look at the histogram we've drawn here, we're doing ages across the x-axis and then frequency going up. So maybe you're at a friend's house or at a gathering, and you'd count how many people are from 0 to 10, 10 to 20, and 20 to 30, and then you would make a tick mark for every age category, and then the histogram would go up to 2 people, 4 people, and maybe 3 people. An example of a bar graph would be if I take the class and I say, how many of you have a purple shirt on today? And 6 people had a purple shirt. Then the next category might be how many people have red shirts. So it's more of a categorical versus quantitative system. With histograms, we also call them bins instead of bars. And you can see that these bins that we have go from 0 to 10, 10 to 20, and 20 to 30. So for example, if somebody is 10 years old, they're going to be in this bar right here, or this bin, because it's 10 is less than or equal to x, which is less than 20. So if you're 20 years old, the 20-year-old goes over in this bin. Okay, so when you look at the example we have here, the bin width, you can't always go by the tick marks, go by the width of the bin. These bins are actually 20 wide. How many values are in this data set? You would follow them across because the y-axis doesn't have a very good scale. We're just going to add up the numbers. 3 plus 9 is 12, plus 20 is 32, plus 40 is 72, plus 23 is 95. So it looks like we have a data set that contains 95 pieces of information. In which bar will you find the 14th data point? Well, in this case, the 14th data point, I would start from this side and I'd move my way left to right. So the first 3 are located in the first bin. The next 9, so I'm at 12 now. So the 14th data point would be located somewhere in the 20, this yellow bar. So I would say anywhere from 40 to 60. Right there. The median, remember the median number will be the middle number. And so out of 95, we want to split that in half. So we would come in, for the median, we'd come in 40, we'd come in 47 from the left, 47 from the right. We've used up 94. That leaves the one number in the middle. So it's the 48th data point. In which bar will we find 48? Again, you can count 47 from the right or the left. So if you count in 23 from this side, you come in 23, you would find yourself in the green bar. Same thing from this side. 3 plus 9 is 12, plus 20 is 32, somewhere in the green bar. So in which bar will we find it? The 60 to 80 bar. What percentage of the students received at least a score of 60? So at least a score of 60, we're going to take anybody that's at a 60 and to the right, larger. So that's 40 plus 23 is 63 divided by the 95 numbers we have. So after some quick math on a calculator, you're going to be able to find that it's about 0.663, which is 66%. In the second example, they give us a little smaller histogram. Notice that the tick marks mark each histogram, but they're only labeling every other tick mark or every other bin. So the first one goes from 0 to 8, 8 to 16. So sometimes it helps maybe to write those numbers in there, but you're seeing that the bin width is 8. And if we carefully go across here, this looks like there might be three numbers here, 5, 6, 7 there. Looks like 6 there, probably 9 there, and 4 there. So if I add those up, 3 plus 7 is 10, 16, 25, 29. So in which bar will you find the median? Again, split 29 in half is 14.5. So I can come in 14 from the left, 14 from the right, and that'll leave me the one number sitting in the middle. So to do this, I would go from the left or the right, and we're going to find the median is sitting in the bar that goes from 16 to 24. What if you get your score back on a standardized test and are told that you are in the 87th percentile? What does this mean? This means that 87% of all students scored below. So a percentile rank is always the amount below you. So if we have 702 people in your class and there are 37 above you in GPA, what is your percentile rank in the class? To be really accurate, I'm going to do 702 minus 38, because I'm taking away the 37 people that are above you, and I'm going to remove the person that you are, right? So you're the 38th person. So if you do 702 minus 38 on a calculator, you're going to get 664. So that means there are 664 people. Normally on a piece of data like this where there are 702, to remove yourself probably won't make that big a deal. But just to be accurate, that's why I use 38 and not 37. So there's 664 below you. So 664 divided by 702 gives us 0.9458. So I would say that that's approximately 95th percentile. Probably to be most accurate, we should say 94th percentile, because really if you say you're in the 95th percentile, there aren't that many people under there. So this is really the better answer. What is the percentile rank of the number 1 student? So if you're number 1, that means there are 701 people below you. So you could calculate it, but really the best we're going to get is 99th percentile. Nobody can ever be 100%. There can never be 100% of the students below you. So I'm going to give you a chance to now look at number 4. Try to create some of these histograms, and we want histograms that have 5 bins for each data set. So look for your maximum and minimum and draw those in. I'm going to pause now and draw my own, and then we'll come back to the video. Okay, let's bring it back. I've drawn my histograms. The SAT scores on the left have 20 students. The histogram on the right for the ACT, there are 30 students, and you can kind of see how I did this. We want 5 bars. So here at the bottom, I made some calculations. you can see that if I take the maximum 790 minus the minimum 350, I get 440. Dividing that by 5, I get that each bar should be about, or each bin width should be about 88. So what I did on the first example is just used a bin width of 90. That's a nice round number. It allows me to start at the minimum 350 and just go every 90. I get out to 800. So there are my 5 bins. The ACT might be a little bit different. When you take 34 minus 18, you get 16, but when I divide it by 5, it goes in there 3 times, but it's really 3.1. So if I only count by 3s, starting at the minimum, I'll get 18, 21, 24, 27, 30, and 33. My 5 bins would not cover that maximum of 34. So because it was 3.1, I just rounded up to 4. So you'll notice on my bin width, I go 18, 22, 26, 30, 34, but then there's no such thing as a 37 on the ACT, so I put 37 question mark. There's just one bin out there. So you could make the adjustment, maybe go down to 17 with the first bin, and then I will finish at 36. But in either case, you see my 2 histograms. They look fairly even as far as the spread of data. So now what they ask us to do is Gwen took the ACT and received the score of 700 in the table above. Evan received the ACT, he had a 29. Calculate the percentile rank of each student to determine who received a better score. So we can take that 700, which would be about right here. And in this case, just looking at the histogram, we could, with reasonable effort here, there are 8, 9, 10 students below the 700 people. There might be, give or take a little bit, but 10 divided by 20 would be 0.5 or a 50 percentile. Now I could order these from small to big and really make a probably a little closer number, but we're just going to use what we're given. And the 29 would be about right there in that bin. So there are a few people in that bin, but for the most part there are 16 people below Evan out of 30. And if you do 16 divided by 30 on a calculator, you're going to get about 0.533. Now that's close enough that if somebody is asking me what the actual percentile rank, I might grab these numbers, order them a little closer, but that's about the 53rd percentile. So Evan scored a little bit higher ranking, if you will. Another student who took the ACT found out that she was in the 60th percentile. How many students scored higher than her? Well, if 60% are below, approximately 40% are above her. So that's the end of the 2.3 lecture.